Welcome back. Here we are at 6.4. We're going to be working with factoring some polynomials, so we'll learn some strategies here. Now remember that if a number is divided by any of its factors, the remainder is 0. So like if I take 15 and divide it by 5, there's no remainder. Well, that same thing occurs with polynomials. So the remainder theorem basically states that if you take a polynomial and you divide it by its factor, it should equal 0. Okay, so that's kind of what we're talking about. So what we can do is determine whether each given binomial is a factor of the polynomial. We just use synthetic division, so let's try that. So on problem A here, let's put -1 into the magic box. And of course we have our coefficients 1, -3, and 1. And if we go through that and the synthetic division process, okay, we get 5 for remainder. Well, that means it's not a factor, otherwise, because it didn't divide in equally, the remainder wasn't 0. All right, let's do the same thing for B here. Again, we're going to put -2 into the magic box. All right, and we're going to take the coefficients 3, 6. Notice there's a 0 there for x squared, a -5, -10. Drop the 3 like it's hot. There we go. We get -6, added 0. That's 0, 0, 0. -5, we get 10. Oh, look at that. Hey, the remainder is 0. That means x plus 2 is one of the factors. So again, do the synthetic division. If you get 0 for a remainder, that means it's a factor. If it's anything else, it is not a factor. All right, so we have some other ones here we can try. Just taking a look ahead. I think we're okay on that. So let's skip ahead here and let's talk about some different degrees of some things that we learned here. Some factoring strategies that we have. We're going to introduce a new one today. It's called factor by grouping. And what you're going to do, if you have 4 terms, what we're going to do is we're going to group the first 2 together and the second 2 together. And if we group the first 2 together, you notice we can take an x squared out of those. And we're left with x minus 1. All right, now in this one, I can take out a -25. And careful, if I take out a -25, it leaves me with an x. If I take out a -25 there, it leaves me with a -1. All right, so notice I have the same thing there, and that's what we want. All right, so what I can do is I can rewrite this as x squared minus 25 in one parenthesis, and then the other parenthesis is x minus 1. You might be thinking, how do we go from there to there? Well, if you think about it, if we factor this, if we distribute it, we are going to take x squared times the binomial x minus 1. And we are going to take -25 times the binomial x minus 1. So we can kind of write it that way, kind of tricky. Now, the other thing is we should look to see now x squared minus 25 is the difference of 2 squares. We know we can factor that into x plus 5, x minus 5. And then we have x minus 1. Look at that. Okay, so then we could say, well, the zeros are -5, 5, and 1. But that's our factors right there. Kind of slick way of doing it. Factor by group. That's when you have 4 terms. We're going to do that. Let's try the same thing over here. We're going to put these 2 together. So we're going to take out, looks like an x squared. And looks like we'd be left with a 2x plus 1. Here, let's take out a 4. And we'd have 2x plus 1. You always want the same thing in there. So that allows us to rewrite this as x squared plus 4 in parentheses and a 2x plus 1. And there we are. Can't really factor anything else there. That's a plus right there. So yeah, so we're all good to go there. All right, so now there's some special rules here as well. So keep in mind of these now. You know, when we had a difference of 2 squares, we knew how to kind of factor that. Well, now if we have a sum or difference of 2 cubes, this is how we factor it. These are the factor rules there. So what you got to figure out is, you know, that number, there are perfect cubes, you know, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. It's kind of important to know those as we kind of go through here. So let's see what we can do with a couple of these rules. First thing you should always do is take out whatever's in common. And here we can take out a 4 and an x. And so we'd be left with x cubed plus 27. And this is a sum of 2 cubes. What we notice here is that x cubed obviously is cubed, but 27 is actually 3 cubed, isn't it? So when we factor this, we just use our cube factors. This will be a sum of 2 cubes factor. It's going to be x plus 3. And then remember, we go x squared. And then it says minus, well, take a and b, multiply them together. That's going to be a 3x. and that's going to be plus 9, and it's all factored. That's it. Okay, yeah, so we got to get that down to a factor. Now this one, we notice that, oh, this is really 5. Let's see, let's get that down. This is really 5d cubed minus 2 cubed, isn't it? All right, so that's a difference of 2 cubes. All right, so the first thing it says for us to do is to take, well, a minus b, 5d minus 2, that's in here. Then we're going to square a, so we have to go 25d squared, and then we're going to multiply those together. Remember, that's a 2. All right, so we take 2 times 5d, that would be 10d, and then we'd square this one, so we'd have a plus 4 is what we'd end up having there. So there it is. That's the difference of 2 cubes there. Yeah, so we got to recognize those cubes. Use that little rule sheet that we had, the one I referred to, of course. If we go back, it's this one right here. Okay, you got to remember that one. Use that as a guide. That's going to be helpful. All right, let's try. No, we don't need that one. All right, and then the last one thing we have here is talk about this is that identify the values which makes the function 0. So again, whenever we graph it, a good tool to use is where it crosses the x-axis. So we can see here it's at -5, -2, and 1. Those are the actual values there. Those are the zeros. So by graphing it, it makes life really easy for us, is what we have there. All right, so on this case here, same kind of thing. Looks like we'd have -1. Looks like we'd have 3 and 4. Those would be the ones that we'd have